Hi.
Hi, are you sure this course is just for 2499?
Yes, and you know this is the only course with this expertise across the world.
No way!
Yes way. Don't delay. Enroll now. Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes way. Don't delay and enroll now.
Geeks learning together.
Hey, hi everyone. Welcome back to this Learn and Earn series. And this is day 29th. And I'm very pleased to see you all here. I hope all of you are doing extremely well. So, quickly in the chat section, can you all please let me know if my voice is clearly audible and if my screen is clearly visible? Okay, so hi Naikaj. Yes, your attendance has been marked. Hi Meshkat. Hello Sachin. Hello Rahul. Thanks Abhinav for confirming. Thanks Sachin. Thanks Venkat. Okay guys, so this is our day 29th, right? So I mean we have been consistent now for quite a long day. Like 29 is like a good number. So what is the maximum streak that you all guys are having? Great, that's very great to see Sachin, Naikaj, all of you did a very great job. This is quite a good number. And also I would request you all, whoever has joined this session, please give a thumbs up on this video. I just want the number of audience and the number of likes on this video should be equal. So that's great, Meshkat. All of you have done quite a good job. Like this is great. Yes, nice Adarsh. 29 is very good. Let's just wait for 1 or 2 more minutes so that our fellow friends can join. And then we shall be starting with our today's session. And also, it is very nice to see that on day 29th as well, all of you are showing such a great excitement for the questions. So that's nice. Okay, I guess we are good to go. All right. Quickly in the chat section, everyone, please give me a +1 if we are good to go with today's session. Hi, Shubham. It's Suniti. So yes, guys, in the chat. Okay, all right. Thanks, Mishkat. So today we will be basically targeting matrix problems, right? So that is our agenda for today. So let us start. The first question is spiral traversal of a matrix. Okay, just a second. Uh, yeah, for our fellow friends who will be joining us a little bit late. So yeah, the first question of today is the spiral traversal of a matrix, right? So in this, what we have to do is, as the name itself suggests, the matrix is given to us and we have to do a spiral traversal, right? Okay, link. Link will be added in the description section as well by tomorrow. So for today, you all guys can go to the link that I've shared. Hi, Sushant. All right. So we have to do the spiral traversal of a matrix, right? Now, let us see what exactly we have to do. So say we have a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. This is our matrix, and by spiral traversal, what we mean is, okay, so first of all, we will be traversing from here to here, right? Which is from left to right. Then we will be doing like this, cool, which is from upward to downward. Then again from here to here, which is from right to left. And then from here till this point, okay, because the upper row has been covered, right, till 5, okay. So in the next iteration, similarly, we will be traversing from here to here, then this only, okay, because this last row has been covered, and then this. I'll just write the output that we will be getting. Okay, output for this will be 1, 2, 3, 4, 8, 12, 16, 15, 14, 13, right, 9, 5, 6, 7, 11, 10. Okay, so is the example and the output of this matrix clear to you all? What do we exactly mean by spiral traversal? Quickly let me know in the chat section if this is clear. Great, Mishka, that's nice to know. Okay, Shagun, thank you for your response. All right. Thanks, Rahul. Thanks, Sushant. So this is clear to you all, okay? Now, all right. So tell me exactly what we are doing. This spiral traversal is basically about just some calculations over the matrix, right? How we are increasing our row number, how we are increasing our column number. All right. It is mainly about that. So let us say number of rows is R and number of column is C. So in first step, what we are doing? We are traversing first row, right? Is this clear? In first row, what we are doing? We are traversing from first row. Let us say we are starting from L is equal to 0. We will take some initial variables and K is equal to 0, okay? All right. And we will be running, let me create a new matrix. Wait. 1, 2, 3, 4. Okay, say this is our matrix, right? Now, let us say we are taking two variables, K0, L0, okay? Why K and L? Because one to keep track of the number of rows and one to keep track of the number of columns, okay? K is for number of rows and L is for number of columns, okay? Now we will be doing it in a while loop. Like everyone agree, we will need a loop for this, right? Because we are doing a traversal. So our loop will be valid till the point while K is less than M and L is less than N, okay? Is this step number 1 clear? Okay, thanks everyone. So now see, let us start our traversal. See, first of all, what we are doing is we are traversing in this first row. Okay, so let us say we have a variable I with us, the most favorite variable. So that we are starting with what? We are starting it with L. L is what? The number of columns. So we are starting it with the first column, right? Whenever you will start traversal, how you are traversing? You are starting from the first column, right? And you are traversing till the end of the column. Cool. So till I is equal to L and I is less than N, I plus plus. Okay. What we will push back in our vector? We will simply push back whatever value is stored at Ki. What is K? K is the current number of row. Is this step number 2 clear? For this traversal, okay, when we are traversing left to right. Let me, yes, this is our left to right traversal. How we are starting our traversal is, first of all, you will start from the first point of the column, okay? We are traversing from the first point of the column to the last point of the column, right? So what is the first point of the column? Column is starting from L, column is ending at N, okay? And K is the current row, right? So as you can see, K will remain constant, right? The row number is remaining constant, only the column number is changing. Okay, so here we have kept the row number constant and column number is continuously changing, and that's how we will be pushing the elements. So after this step in our vector, elements will be 1, 2, 3, 4. So first traversal completed. Okay, is this clear to you all, this first traversal 1, 2, 3, 4? Okay, thanks, Meshkat. Right. Now, just let me know one thing. Once you have traversed this row, okay, this row is completed. This row was k is equal to 0. Now, after traversing this row, what could be done so that in the next iteration, this row is not covered? Like this row was for k is equal to 0. Which variable should we update so that in the next iteration, we will not be covering this row? If k is equal to 0 has already been covered. Okay, we have a k plus plus here, and Naikaj is saying k. Shubham is saying k plus 1. Okay. K plus plus, Kishore, okay. All right, Narsimha Rao is saying k. All right, see, if once you have traversed this row, then we don't need to consider it again, right? So this was point k. So to start the iteration from the next point, we need to do k plus plus, right? Getting my point? Why we need to do k plus plus? Because this has been covered. Yeah, exactly. K should increase because this row you have been you have covered. Okay. So now to move on to the next row, we will do k plus plus, which is our step 3. Cool. Great. So let us now start with our next step, which is our next traversal. So as a part of our next traversal, what we will be doing is we are traversing from here to here, right? 8, 12, 16. Now tell me in this traversal, uh, let me start. I will start my I. I is starting from which point? In 8, 12, and 16 when I'm traversing. What is the first row number for, what is the row number for 8? What is the row number for this row? 5, 6, 7, 8. What is the row number for this row? 1. Okay. Yeah, exactly. We are not going to take 1 here because every time we need to do the spiral traversal, right? So if you will do 1, then every time it will start traversing from this point, but we don't want that. Actually, we have correct answer by Sachin. The row number for this row is actually k, right? We are here talking in terms of variable because, if you will take it as 1, then in all the iterations, it will be getting started from 5, right? So that's why we don't want that. So let us only talk in the terms of variable. So that's why our I is starting from k. Cool. Now, I is less than, what is the last row number? What is the row number for this? We are traversing till 16. So what is the row number? Just a little bit of calculations. M minus 1. Exactly. Great, Meshkat. Shagun, that will be M minus 1. I guess you missed that. I mean, yeah, if we are talking less than, I should be less than M. That's correct. Less than is equal to, it will be M minus 1. Okay. and I will be doing I plus plus. Cool. And what will be pushed back inside our vector? Say matrix at point. See here, the column is remaining constant, right? And we are changing row. And what is the column number? That is n minus 1. Does everyone agree this column number is n minus 1? And here we have completed our step 4. Is this clear? And when we will do pushback for this, we will have 8, 12, 16. Okay, great. Great, everyone. Now, tell me one thing. Say once you have traversed this row, this column. This column has been traversed, which is column number n minus 1. Now, uh, yes, Naikash, the logic is correct. We are definitely going to do that. So now tell me, what are we going to decrement now to keep the count that this column has already been traversed? Like in this case, we did a k plus plus, right? So now how to decrement this column variable? Okay, what is L? Actually, yes, you all are correct. Actually, it will be n minus minus, okay, not L minus minus. Great. L is actually keeping the count of the starting column and n is keeping count of the end column, right? Like I will just explain. K is the starting row and M is the end row. Okay. So similarly, L is the starting column and N is the end column. Okay. After every iteration, we will be doing K plus plus M minus minus. Again, we are starting L from starting column. Yeah. L will be doing L plus plus and with it will be doing N minus minus. These are the 4 key points for the traversal. Is it clear? These 4 points are clear. And thus, while k is less than m, the loop will be executed. And while l is less than n, the loop will be executed. Okay. Okay, so this is the gist of the question, how we are traversing. Cool. So yeah, we have done n minus minus step 5. This is clear. And now, I think we will need a new page again. Okay, so now tell me, when this traversal is done and this traversal is done, now I am starting for this, okay? So what will be this? I is starting from which point? What this point was n. So can I tell that this point is n minus 1? This is n minus 1. Okay, great. So I is starting from n minus 1 and till what point? Till I is greater than the starting column. Okay, like L was the starting column now, so we are traversing till 13th here. Means the first row hasn't been traversed yet, so we'll be traversing till the starting column of this, and we will be simply doing I minus minus. Okay, and if in that case, what we will be pushing back? In this case, what is remaining constant? Tell me, the row is constant or the column is constant? The row is constant. I should be the row number or column number? Okay, row number. All right, tell me when you are doing 15th, 14th, 13th. So are you changing the row or are you changing the column? Exactly. Great, Shagun, Meshka. That's the right answer. We are changing columns, so we will put our I here. And what is this row number? Agree why this is m minus 1? So the row number is m minus 1. Okay, this is step 6. Clear to you all? And after this step, our matrix will be 15, 14, 13. I mean, in our answer vector, we will be pushing back this. Okay. And after doing this traversal, we will be doing m minus minus, right? Because now our m is here. We want it to move a step upward because this row has been traversed. Okay. So if this row has been traversed, this was m minus 1. So now we will decrement the value of m. Okay. As we know, increment the value of k, decrement the value of m. Okay. Is this clear? And as for the last iteration, which is this part, what we will do is, let me take a tell me from where to where the loop is going to start for the last traversal. Any ideas? Column is constant, row will increase. Okay, that's correct. So in P back, we have a constant column. And can you tell me what is the name of that constant column? Which column is this? I will start from, yes, Meshka, that's the right answer, but it will be like, m minus 1. And then we will traverse till I is greater than k, because this is the value of k. And, this is keeping the track of the number of columns, sorry, number of rows. So I should be greater than k, and then we will decrementing I. And what column number is this? This column number is taken care by L, and here we will write I. Is this clear? And actually row will decrease. Row is decreasing here, okay? Because we are moving from down to up, so row is decreasing. And after this, the elements inside our vector will be 9, 5. And then again, for the next traversal, what will happen? K has been come here. All the 4 steps will be repeated, okay? What we did in this, all of will be repeated, okay? All those steps will be repeated until and unless k is less than m and l is less than n. Yeah, RC, yeah, exactly. In the question, we are going to take that variable only. I'm sorry, here I have taken this. So, all right, all these 4 steps are getting repeated again. So, what are the 4 steps actually? So, the first step is travel first row and do k plus plus. Second is travel last column and do n minus minus. Third is travel last row, do m minus minus. And fourth will be travel first column, and after traversing first column, what we will be doing L plus plus. Okay, are these 4 steps clear to you all? First means the initial row, which will keep on changing after every traversal. Are these 4 steps clear? Give me a +1 if we are good to go to the coding part. All right, great everyone. So yeah, here we are going to take R and C so that there will be no any confusion. First of all, let us create our answer vector. Great. Okay, so first of all, we are doing left-right traversal. Okay, if any confusion in this coding part, do let me know, all right? We will be pushing back. The row number is constant. Matrix. Okay, so what is the row number for this? And column number is changing. What is the row number for the first row? Which variable is indicating that? Tell me guys, which variable is indicating the first row? L. L is actually the column number. K. Okay, great, Shagun. That's the right answer. K is our first. Yes, Narsimha, that's the right answer. K is our first element. K is our row number. Okay. And now after that, we will do K plus plus. Clear? Now let us move towards our next traversal. Here, I will start from the last row number. So what is our last row number? That is C minus 1. Right? Okay, I is greater than is equal to M minus 1. That is R minus 1. And we will be doing I plus plus. Sorry. Number of row is R. This is kind of... Okay, now tell me, what is constant here? Row or column? I will be row value or column value? Column value. Okay, are you sure we are changing the column? We are traversing from upward to downward. Okay. So, and the row number is n minus 1. Sorry, the column number is n minus 1. Okay. Once this traversal is done, we will do n minus minus. Now we will check if k is less than m. Sorry, k is less than r. Yes, column is constant. That's right, Nikaj. Row is incrementing. Yes, Meshka, that's the right answer. Now for int I is equal to minus 1, I is greater than is equal to k. We will be doing I minus minus and in pushback. All right. So when we are traversing from right to left, okay, this is right to left traversal, then in this case, what part is remaining constant? Row is constant or column is constant? This will be column is decreasing and row is constant. Great. So means I we are going to put here and the column value we have is r minus 1. Okay. And then after doing this, we will do r minus 1. We'll decrease our row value. Row constant. Yes, Nikaj. Yes, that's correct answer, Meshkat. And again, we will check if L is still less than C. Okay. Just take care of the variables. Actually, I don't know. Maybe I have done some mistakes. Just keep the variables in track. So when we are traversing from, say, downwards to upwards, we are going. So in that case, the first value that we have will be n minus 1, right? No, first value we are going to have is r minus 1. I should be greater than is equal to what will be the last value? That will be k. We will be doing I minus minus. Okay. So now tell me, when we are traversing from downwards to upward, what is constant here? While traversing downwards to upward. row decrease, column constant. So row is decreasing in this way, and the column is constant, which is L, right? And at end, what we'll be doing, we will just do an L plus plus. Row decreasing, yes everyone, that's the right answer. And by the end of the loop, we will returning our answer. Okay, there might be some mistakes in the variable k plus plus n minus minus. What is n? That will be actually c minus minus, right? K plus plus and L plus plus, c minus minus, r minus minus. Okay, let's see if we have done this correct. This is thoda sa confusing because we have lots of variables here. Okay, n is, yeah, cool. This will be c. Is the logic part clear to you all? Rest is all about, the, okay. Rest is all about, just it's a logic that how we are increasing the row number, decreasing the column number. Okay, great. We have coded it correct. So yeah, is this question clear to you all? Is this code section clear to you all? What we are doing? See, as I said, simply do this k plus plus, increase the initial row number, and then increase the initial column number. Okay, keep on decreasing the final row number and keep on decreasing the final column number. All right, so that is the main concept behind this question. Give me a quick +1 everyone if we are good to start with our next question, and if this question is clear to you all. See, variable, I guess we have two variables only, k and l, right? Like r and c was given, that is the constant, I mean that is the row size and the column size. So we have used two variables only here. I mean, do you have any approach that we can do without using this k and l? If that's what you mean. Okay, you can share our approach if you are having anything in your mind like that. All right, so now let us move to our next question. And quickly, let me share the banner for this. Okay, so all right, Nagas, you can share your code in the Discord channel, right? That will be of help to our fellow friends if you are having any approach like that in your mind. Okay, so now before moving on to the next question, I want you all to please give a like on this video. Everyone who's watching this, I want the number of viewers to be equal to the number of likes on this video. So yeah, everyone please do that. Great. All right, so our next question here says, yeah, thanks Meshkat for reminding me. I guess, okay, the space complexity, can anyone tell me what will be the space complexity? Of this question? This is very clear what is the space complexity. Okay, let us not take into account this answer vector that we are returning, okay? Because this is our answer vector that we are returning, so we don't need to count this. Except for that, is there any other data structure that we have used? Exactly, so the space complexity is going to be constant. All right, and what will be the time complexity? Yes, everyone, that's the right answer. Naikat, Mishkat, Sachin, that's the right answer. We have used a constant space. And what will be the time complexity for this? Exactly, time complexity will be R into C because we have done the entire traversal of the matrix. Okay. Great. Now let us move to our next question, which is unique rows in a Boolean matrix. So the statement reads as, given a binary matrix, your task is to find all unique rows of the given matrix, okay? So as we can see here, we have our matrix as, just a second. Okay, again, thanks Mishkat for asking for the link. I'll just share. Okay. All right, and let me change the banner as well. Right? So we are here doing unique rows in a Boolean matrix. So let us say, for example, 1101 and 00. Okay. Say if this is a matrix given to you, then how many unique rows are there in this matrix? Is this row unique? Of course, we are visiting it for the first time, then maybe we can keep it in our answer. Is this row unique? We can keep this as well in our answer. Okay. Can we add this in our answer, this row? Can we add this row in our answer? No, exactly. So number of unique rows we have is 2, okay? So is the question statement clear to you all? No, Naikad, see, a unique rows means, see, this row is 1101, right? This row is 1001 and this row is 1101. All right, so as you can see, this row and this row are same. Cool. So that's why the unique rows are just, we have 1101 and 1001. If only zeros are there, I mean, if the row elements are only 0, okay, you got it. All right. So, okay, tell me one thing. Whenever you listen the word unique, okay, what is the first thing that comes in our mind? Like which data structure is going to be our best friend? You know, there is a data structure, exactly, because that's right answer. I want everyone. Yes, Naikaj. Exactly, Shagun. That's actually a very precise answer that we are going to use in this question. All right. So see, the idea here is again hash. Okay. Hash, you know, you can use either hash map or you can use hash set, whatever you can use, that is according to, you know, your convenience. See, here, the thing is distinct. Some keywords are, that we have distinct, unique. Cool. So maybe we can use hash set here, right? Look, if you will only take frequency, then you might miss out the order. Like say if one row is 1001, 0011, they have the same frequency, right? But still they are unique rows. Cool. So we need to take into account the order as well. So we are going to use the set in this question. So what we will be doing exactly is, this is our matrix. Now, while we are traversing this row, what we will do is, say we will create a string and we will add all the values inside it, okay? And then we will be having a set with us and we will check if this value is already present inside our set, then we will not add it, and if it is not present, then we will add it to our answer vector. Is the logic clear? What are we going to do is, first, use of unordered set. Second, check if string is present. All right. Third, if not, then add it. Are these 3 steps clear to you all? Okay. Can you tell me what is the time complexity for an ordered set and time complexity for unordered set? Do you agree with this? Because in ordered set, elements are always inserted in a sorted order, right? Here we don't need to keep, see whether you are increasing, whether you are inserting 1101 first, or whether you are inserting 0001 first, it will not create any difference. We just need to check that if the element is present or not, right? We don't need to check, which we don't need to sort them. Sorting is of no any help here. So that's why we are just going to check that if elements are present or not. And so to save some time complexity, we are using unordered set here. Okay, that's a very good question, Sanchit. I'm very happy you asked it. So is everyone clear on this part, that why we have used unordered set and not an ordered set? Because here the order is not mattering, right? Order in which we are inserting the data, that is of no any importance to us. All right, so that's why we are going to use unordered set. Cool. Okay, so now give me a +1 if we are clear on this logic part and we are good to go with the coding. Just take your time to analyze it, and if any confusion you can ask in the query. Yes, you can use, unordered map string int, and then you can increment the count of the current string that we have. Map can also be used. But in map, there is a key and a value pair. But, when we are using set, we just have to add only one element. So that's why we are using set here. Because here in this question, what is happening? We only need to add unique elements. We don't need to count how many times a number is appearing, right? So that's why maybe we are using a set here. But yeah, anyways, it can be done with the help of map as well. Okay. So let us say this is our answer. Now, we will be traversing for all of our rows. Let us take a temporary string. Let's take a temporary vector. Okay, see, when you will convert it to decimal value, what you will need to do is, multiplying by 10 for every iteration. So maybe that will take some time. So maybe we can avoid that with just use of strings. See, unordered set and unordered map is going to take you the same time. Okay. So both of them is having the same complexity. Exactly. String, it is easy to apply kind of. So that's why, let us say unordered set string is MP. Now, for int, all right, let me just do this question completely. Okay, once this question will be completed, then maybe we can move towards the time space complexity and time complexity. Okay, we will be analyzing it. All right. So now we have our string ready. Have our temporary vector ready. Now tell me, what do I need to check here? Once I have traversed everything, what do I need to check? My string is ready and my temp is ready. Like I am having the values that are in current row. Okay, those values that I have in string and temp. So now help me, what do I need to check? Size. Okay, how is size going to help us? Insert. All right, we are going to insert, but before inserting, what are we going to check first? If it is correct, we are going to insert the string, but before inserting, what you will check? Equal to is equal to mp dot end. All right. Maybe you can help us with that. How can we use XOR here? Yes, because that's the right answer. Then mp dot insert str and rest dot pushback temp. Okay. The current row, we need to add it inside our answer vector. Then at the end, we will be just returning our answer vector. Okay. Now let me quickly check if that is the correct answer. Seems like it is. All right. So here is the code. If any questions, any confusions, please do ask in the comment section. Or if there is no any questions, then you can all give a +1 if we are good to move to our next question. Yes, exactly, Meshkat. Whatever you are saying is correct. Set will insert an element if it is not present, and that's exactly that we want, right? We want an element. We will be inserting this string only when it is not already present, because we want to avoid the duplicacy, right? Okay, max, where we have taken. Okay, so see, whenever you pass array, so you need to at least have the upper bound of the total number of rows or columns that you are having. Okay, Meshkat. So you are saying that if we are using set, then we don't need to use this check function, right? But we need to use this check function, because then how you are going to check if we are going to do this rest dot pushback or not? For set, it is fine. Okay, it will only insert the new elements, but when you are pushing it inside your answer vector, for that you need to have this condition. Exactly, set is not accepting the duplicate elements. That perfectly correct, but for the answer vector we need to have this condition. Like, how are you going to decide if you are going to push the current row inside your answer vector or not? Clear? So yeah, everyone, please give me a +1 or any queries. Then do ask that in the chat section. Okay. Great. Thanks, Dikers. Thanks, Sheikh. Thanks, Shubham. Okay, space complexity and time complexity. Let us discuss about that. So, okay, don't take into consideration the answer vector that we are returning. Except for that, what will be the space and time? Yes, Nikaj, your conclusion is correct. Time complexity n square, that's perfectly right, Shubham. And the space complexity? N cross M. Okay, I think we have used a linear data structure here. Look, in case of space, what is happening is, let me just explain you. So what is happening is every time you are inserting a string inside it, a new string is getting inserted inside the map. And what is the maximum length of that string? That will be number of columns, right? Is this clear to you all? Okay. So now tell me one thing. In the worst case, what will happen? Say we have all the rows that are unique inside this matrix. Okay. So you will need to add all the rows inside your set. Is this clear? You need to add all the rows. So we have added rows, all the rows, and the length of each of the row is column. So isn't the space complexity rows into column? Is this clear? R into C will be the space complexity. Clear? Okay, great. So now, thanks, Sachin. Everyone, please give me a +1 if you are good to start with our next question. Okay, actually, in today's session, we are discussing this matrix problem. And for these array questions, maybe you can, visit the other videos of this playlist. And from there, you can get the idea of the complexities, okay? So that will help you. Okay. So this question says is, we need to find kth element in matrix. And what is it about? We are given a n cross n matrix where every row and column is sorted in non-decreasing order, right? And we need to find the kth smallest element in the matrix. All right. So let us see. For example, all right, see, this question I'm going to do with one approach. I want you guys in today's homework to do it with another approach, which will take less time complexity than the one which I'm going to discuss here. Okay, so that will be today's task for you all. And thanks, Mishkat, for again reminding me. And let me. Okay. All right, there are multiple approaches for the question. All right, I'm going to do with one of the approach and the other approach that you guys are going to do in today's homework. Cool. So see, here we have question as, we have matrix say 16, 28, 60. It is sorted, right? And we need to find the third smallest. All right, so by looking into the matrix, can you guys tell me what is the third smallest element here? 16 is the first smallest. and 22 is the second smallest, and 27 is the third smallest, right? Okay, have you guys done this question? Kth smallest element in an array? Okay, let me discuss over some keywords here. Whenever the keyword is kth, okay, whether it is smallest or largest, what is the first data structure that comes in mind? No, we don't need exactly sorting here. We need sorting, but actually, there is a data structure that we can use which can avoid doing sort. Exactly. So everyone, Rohan, Naikaj, that's the right answer. See, whenever the keyword is kth, keep this in mind. We are going to use a priority queue. Okay, what does the priority queue implement? I mean, what is it is exactly going to implement? We are using priority queue as heap. Exactly, that's the right answer. So there are two kinds of heap, max heap and min heap. Now the second keyword. If in the question the keyword is smallest, in that case we will be using max heap, and if the keyword is largest, in that case we will be using min heap. All right, keep these three things in mind. Okay, are these 3 points clear to you all? Great. Yes, exactly. That's the difference between max heap and min heap. So keep it in mind. Now let us look at our question. Our question is kth smallest element. So, okay, can you tell me what are we going to use here? First, see, the question is kth smallest element. Cool. So now tell me what are we going to use here? The kth keyword is there, which means we are going to use priority queue. The smallest keyword is there, which means we are going to use, sorry, max heap. Is this clear? Which data structure we are going to use? And as it is saying, we only need, see, let us say this is a max heap. Now tell me, in max heap, this topmost element, is it the max element or min element? The topmost element in a max heap. Exactly. Thanks, Meshkat. Thanks, Sachin. That is the right answer. The topmost element is the max heap. Okay. So what we will do, we only need the kth element. Okay. So every time the size is getting greater than k, size will be greater than k, we will just pop the top element. Okay. So that at the end we only have with us the kth smallest element. Okay, so that is the logic. And this same trick you can use for the arrays as well. We have this question for the arrays, like the kth smallest element in an array. In that as well, you can use max heap, and every time the size of the heap is getting greater than k, just remove the topmost element. All right, so let me just move to the coding part. Any doubt, do let me know in the chat section. Thanks, Mishkat. Okay. Everyone, please help me with the time complexity of this code actually. What is the time complexity? Time will be k log n for k is iterating over matrix and log n for inserting elements in priority queue and at last fetching. All right. And space complexity? What will be the space complexity for this code? Yes, you can say that's a linear space complexity. All right. Now see, while doing this question, what I have done is I have traversed for all the elements of the matrix, right? Now, I want you all to do is like solve this question without traversing all the elements, right? So that is the homework that you have for today. Like you have to solve this question, but without traversing the entire matrix. Like use this fact that the matrix are sorted. Like if the matrix are already sorted, then maybe we can avoid traversing through all the elements. Okay, getting my point? So that is what you all will be doing for today's homework part. And now, yeah, we are done with this question. And actually, we are done with all the three questions. So if any doubt in any of these three questions, do let me know. Yes, Rohan, your intuition is correct because as it is sorted, so binary search is going to help us. Now I want you all to, just do that question and post it in the Discord channel. Yeah, so if any doubt in any of these questions, any feedbacks about the session, you're most welcome, Shubham. In tree, when we insert the data, that is not in sorted order, right? But we in heap and order is always maintained. Do you want the same series to be there again? If it is, then maybe we can talk to our team and we can ask them for the same series. That's very nice to hear, Shubham. In fact, I actually like the series as well. Interacting with you all was really very great. And I really look forward to these sessions. So that's really nice. So yeah, okay. See one. Yeah, heapify process takes login. That's correct. All right. See, one of the questions for the homework I have given to you all. Two more questions that I'll be adding in the Discord channel, and all right. Keep on solving the questions. Keep on doing the hard work that you guys are already doing. And Geeks for Geeks is there to help you with your practice. The more consistent you will be. Thanks, Nikaj. So the more consistent you all will be, more easier it will get you all to achieve your dreams, right? So keep on doing the hard work. Yes, Shubham, that's right. GFG kar lo, ho jayega. That's very nice to see the enthusiasm and excitement that all of you are showing. So that is all about today's session. Thank you all for attending it. And if there is anything else, if anyone wants to add. All right. So yeah, okay. So keep up the hard work, right? You're most welcome, Shagun. Keep on solving the questions. Geeks for Geeks will be back with more such interesting series and more such interesting things for you. Thanks for having thanks for joining the session. And yeah, good night. Have a great